Right now, your brain is processing trillions of bits of information to convince you that the world around you is real. The weight of your phone, the smell of the air, the coldness of a glass of water. But what if I told you that every star in the night sky, every memory of your first love, and every atom in your body is nothing more than a line of code in a cosmic supercomputer? What if the Big Bang wasn't an explosion of matter, but a power-on switch? We are no longer in the realm of science fiction. In 2026, the question is no longer, is it possible, but how do we find the exit? Welcome to Deep Science Explained. The simulation hypothesis is perhaps the most haunting mystery of the universe.
It suggests that a high-level civilization, perhaps our own descendants, has reached a point of technological singularity where they can simulate entire universes with conscious inhabitants. If they can create one simulation, they can create millions. Mathematically, this means the odds of us being the base reality are billions to one.
Today, we aren't just looking at philosophy. We are looking at the hard, deep science of glitches. From the impossible limits of quantum mechanics to the strange mathematical codes hidden in the fabric of space-time, we are searching for the fingerprints of the programmer. If we are living in a digital construct, there must be a resolution limit. There must be a boundary. In the next few minutes, we will explore the experiments currently trying to break reality and the terrifying implications of what happens if we actually succeed in proving it. To understand if we are in a simulation, we have to think like a software developer. If you're building a massive open-world game, you don't render the entire world at once. That would crash the system. You only render what the player is looking at. This is called occlusion culling. But here's where it gets crazy. In the world of quantum mechanics, we see something eerily similar. It's called the double-slit experiment. When physicists observe a particle, it behaves like a solid object, a rendered bit of matter. But when no one is watching, it behaves like a wave of probability. It's as if the universe only calculates the position of an atom when it absolutely has to, saving processing power for the rest of the simulation.
Did you know that there is a fundamental pixel size to our universe? It's called the Planck length. It is the smallest possible measurement of distance, roughly 1.6 times 10 to the negative 35th meters. Below this limit, the laws of physics simply stop working.
In a digital photograph, if you zoom in far enough, you eventually hit the pixels. Is the Planck length the pixel of our reality? Are we living in a universe with a fixed resolution? Science explained simply. If the universe is a simulation, it must have a finite amount of memory. This means that at extreme scales, like the highest energy cosmic rays, we should see rounding errors. Just like a computer struggles to calculate the number pi to infinity, a simulated spacetime might show subtle stutters when pushed to the limit. Currently, researchers at Deep Science Explained are monitoring ultra-high energy particles coming from distant galaxies, looking for a specific kind of grid-like behavior that shouldn't exist in a smooth, natural universe. The limits of computation also bring us to the concept of computational complexity. The universe is an unimaginably complex machine. If every single atom's position, spin, and velocity had to be calculated perfectly in every fraction of a second, the processing power required would be infinite. A simulation would have to find shortcuts. We see this in renormalization, a mathematical trick physicists use to manage infinities that pop up in quantum equations. Is renormalization just the simulation's way of simplifying the physics to keep the program running smoothly? Are the laws of physics optimized for computational efficiency rather than being natural or fundamental? This suggests that the universe has a finite computational density. If we push the calculations too hard, by smashing particles together at massive energies or trying to observe too many things at once, we might cause the simulation to stutter. Think of time dilation in Einstein's special relativity. As you move faster, time slows down. Is this just the simulation allocating more processing power to your movement by slowing down your internal clock? It's a mechanism to ensure that no sprite, no matter how fast it moves, can ever exceed the simulation's refresh rate, which we call the speed of light. But the glitches go deeper than just pixels and computational shortcuts. In the 1990s, theoretical physicist James Gates Jr. was working on the mathematics of superstring theory. the attempt to unify all forces in the universe. He found something that sent shivers down the spine of the scientific community. Deep within the equations that describe how quarks and electrons move, he found error-correcting codes. These are the exact same mathematical strings used in web browsers, like the one you're using right now, to ensure data isn't lost during transmission.
Why would the natural world need a browser's error correction code? It's a paradox that suggests the laws of physics aren't just like code, they are code. What if the reason we haven't found aliens yet, the famous Fermi paradox, is because they haven't been loaded into our simulation? Or worse, what if we are the only conscious sprites in a universe designed solely to see how long it takes us to realize we're in a box?
This leads us to the problem of observer effects. In quantum mechanics, the state of a particle changes the moment you measure it. It goes from being in multiple places at once, a wave, to being a single defined spot, a particle. It's called wave function collapse. But what counts as a measurement? Does it have to be a conscious human observer? If it does, it suggests that consciousness is not in the universe, but rather part of the apparatus that runs it. Consciousness is the render command. In a simulated universe, a mind is required to pull the quantum code into a physical reality. Deep Science Explained has to ask, if we are simulated, does this mean base reality is a place where mind and matter are the same thing? If consciousness is required to render the universe, it means we are not passive observers. We are an active part of the program's feedback loop.
This has profound implications for our understanding of free will and human agency. We might be the simulation's way of exploring its own possibilities.
The concept of a code also implies a standard or a compiler. If you write code, you need a program to interpret that code into a language the machine understands. For the universe, what is that compiler? Modern physics is currently stuck between two massive theories that refuse to merge. General relativity, which governs the large-scale universe, gravity and space-time, and quantum mechanics, which governs the very small. When you try to combine them, the equations break and you get infinite. It's as if they were written on two different coding languages by two different teams of developers who never talk to each other. The ultimate goal of physics is to find the single, unified language that compiles both, a theory of everything. If we find it, will it just look like a mathematical formula, or will it look like the universe's original source code? If we find the code, we might find the creator. This brings us to the big discovery. It's called the Holographic Principle. It is the bridge between the deep science of black holes and the digital nature of reality. Imagine a black hole. When an object falls in, we used to think the information it carried was destroyed. But physicists like Leonard Susskind and Stephen Hawking realized that the information, the data of the object, is actually preserved on the surface of the black hole, like a 2D label on a 3D jar. Analogously, this suggests that our entire 3D universe, everything you see, touch, and feel, might actually be a projection of 2D data encoded on the surface at the edge of the cosmos. This is the ultimate mystery of the universe. If our reality is a projection, it means we are essentially a hologram. And what is a hologram? It is a piece of information rendered into a 3D experience. As the legendary physicist John Archibald Wheeler once said, "It from bit." Every particle, every field of force, derives its function, its meaning, its very existence from the apparatus elicited answers to yes or no questions, binary choices, bits. Wheeler was suggesting that at the very bottom of reality, there aren't things. There are only bits of information, zeros and ones. The big discovery is that the universe doesn't just look like a computer, it functions exactly like one. This holographic nature also leads to the concept of information entropy. Every system in the universe has entropy, which is a measure of its disorder. But in a digital system, entropy is also a measure of its information density. The universe has a limit to how much information can be packed into a given space. If you try to pack too much data, you create a black hole, which has the maximum possible informational entropy. This suggests that the universe is optimized to manage information. Space and time are not fundamental. They are just variables the program uses to organize the data. This challenges our very understanding of existence.
What if the space between us isn't empty, but filled with the simulation's background data processes? What if the expansion of the universe is just the program expanding its allocated memory? Deep Science Explains suggests that nothingness might just be unformatted digital storage space.
So, could we prove it? If we are in a simulation, the proof might be hidden in the very fact that we are asking the question. A perfect simulation would be indistinguishable from reality. But a simulation created by an imperfect creator, or one trying to save energy, will always have a seam. It will have rounding errors, rounding limitations, or unexpected paradoxes where different laws of physics collide. Perhaps the reason quantum mechanics is so weird is because the simulation doesn't use standard arithmetic. It uses something more exotic, like p-adic numbers or octonions, which would leave distinct mathematical fingerprints in our reality. Currently, experiments are underway to detect a potential anisotropy, or a preferred direction in spacetime, which would suggest that our universe is running on a grid of a specific shape, like a cubic lattice, rather than being a smooth, natural void. We're looking for the orientation of the cosmic processor. But here is the final, reflective twist. If we prove we are in a simulation, does it change anything? You still feel the warmth of the sun. You still feel the sting of a heartbreak. If a digital soul suffers, is its pain any less real? If we are simulated, it means we are the result of a deliberate, intentional act of creation. It means we have a relationship, however indirect, with a higher intelligence.
This doesn't delete meaning, it refocuses it. Our lives become part of a larger, grander narrative, an ongoing experiment to see what consciousness can achieve within the limits of the code. We are not just dust in a natural void. We are data in a divine machine. What if reality itself isn't what we think? What if base reality is something so strange, so incomprehensible, that a simulation is the only way our minds can exist? Perhaps the simulation isn't a prison. It's a cradle, a safe space where we can evolve and grow until we are ready for the power on button of true reality. We spend our lives terrified of a power off switch, but what if death is just the process of being uploaded back to the source code?
I'm your host, and this has been Deep Science Explained. If this journey into the cosmic code made your reality flicker, hit the like button and subscribe. The exit is out there. We just have to keep looking for it. In our next episode, we'll uncover something even stranger, the Boltzmann brain paradox, why it's more likely that you are a lone brain floating in a void, hallucinating your entire life, than it is for the universe to actually exist.